Okay, so we are still on the Linkedlist problems, and of course, I always want to practicing my English skill, and then I relate it to my job where I study. So today we're going to solve problems at the Linkedlist still remove note. So let's read the problems and then try to think about what the approach we're going to come up with. Okay. Remove note. Remove. Okay, remove note. Write a functions remove note that takes in the head of a linked list and a target value as argument. The function should delete the node containing the target values from the list and return the head of the resulting linked list. If the target appears in multiple times in the linked list, only remove the first instance of the target in the list. Do this in place. You may assume that the input list is non-empty, or you may assume that the input list always contains the target. Okay, so the linked list will always be not empty, so not pass any node at the argument, and then always contains the target. But have to think about how about if we pass in only one list, right? It only one node. So and then the target it match with the first node. It means we're going to return nodes because we want to remove the node with it match with the target, right? Okay, that our edge case. And the other one, let's say if we have multiples target, in this example we have h, i, j, and I. We want to remove first I and then we return h, j, and I. Okay, and I say if we have only one node, right? Like t, and then the target is a t. What we return is no. It means, okay, so let's write code this here. We need to have, we need to initialize the variables with content the previous we're going to set to null. Okay, let's prep set to null, and then we're going to initialize the current is set to head because we don't want to we have to have like a list or node to refer or reference to links. Okay, and then we're going to traverse through the linked list and then find the target and the values if they match, and then we want to remove that node. Okay, so while current is not known, we want to do something here, and then while we traverse to the list, we know we want to move is node. Gonna set like current to current.next until we met our target, and then I gonna write here like we return head at the end after we doing things with our linked list. And so we have to check if the current values is equal to target values. What we're going to do here, we want to refer the prep which we set to null to the current.next, and then we can move the current node, right? So prep will move to the current.next and return the rest of the value. So what we're doing here, we're gonna set prep.next will be current.next, and each time when our while loop, right, we iterate through the node, we need to move the prep to the current. So current prep will move to the current, and then after we met the condition, we move prep.next to the current.next, so then we can move the node we want is matching the target. And then we know if we met the values we want to remove, we want to just break out of the loop. So just break, yeah. And then in, let's say, run to see code, yeah, if we passing, okay. So we didn't pass the test one with is say prep.next is not cannot set properties of no to setting next on the when I try to move prep.next. And then to come to see our test case, test 4 or test 2 is not passed because this test case we want to remove the third node. It means, as I say at the first time, we need to start at the end if our head.value before we run through each node, right, is equal to target. What we want to return head.next. It means we remove the fourth node and then we return the next, right, the rest of the value of the list, so that it should be passed. Right? Run to see. Okay, so the test case is passing now. And I do this in the iterative solution. So let me try to do, I'm going to do in recursive way. We don't really need any variables, but the time complexity will be worse because we're going to use the recursive, it means create a stack, right? So it means the time complexity will be O of n, and then space complexity will be O of n as well. With for the iterative solution, let me talk about that later. So let me just walk through recursive one. So as recursive case, we have to think at first our base case. So base case, what I'm gonna do here is similar with what we done last time. So okay, if we have no head, so it means we assume have head. So if the head values is no, or it met to target, target value, that's what we want to return. We want to return head.next. That's what is the same our iterative solution. But I do believe because each time recursive call we want to check if head is no. Yeah, right? Because every time we run the recursive call, we return the new head, right? Until if head no, what we return just no. Yeah, this is our base case. And then come to the recursive case, what we're going to do, we're going to call the function remote node itself, and each time we travel to the list, we want to pass head.next and target values. And then what is head.next return? We return the new head. So I'm going to set the recursive core set to head.next, and that is the value is set to head.next is gonna be remove head recursive core, and then that's what we return. Okay, and then we need to return head at the end because after we move through the list, and then what we're going to return, we want to return the head, right? Okay, then run to see. Okay, that's passing test. Okay, for both solutions, it's kind of like for iterative solutions is better in the runtime because we don't create any space. Runtime is the same, like O of n is linear times, but then for the space complexity for iterative solution is better because we don't really create any space, because we do this in place, right? We not need to create any space for any variables, and then so time complexity will be O of n, and then the space complexity will be O of 1. But for the recursive solution, the time complexity will be O of n, and then space will be O of n as well, because each time we use recursive call is create a new stack until That's it for today. I hope I can have another video next time. Thank you so much. Bye.